Now, in a previous video, we talked about scaling up a database and what are some practices you can do to let that database handle more traffic. In this video, I want to kind of dive into replicas and how replicas work with databases, and more specifically in Postgres. So I'll say replicas. Now, typically, you're going to have a user, and the user needs to fetch something from your API, and the API needs to fetch data from your Postgres database, right? And this works pretty well, but in some scenarios, you may want to reduce the latency so that a user who's potentially living in the West Coast, I'll say like West Coast, they don't have to go and fetch data all the way from the East Coast just to render out that information. But this type of request is going to add on like 100, 200 milliseconds extra latency. Okay, so instead what we could do is we can make a replica like I mentioned. And so the data that's in the East Coast, it can actually replicate to the West Coast replica whenever people try to insert data. So you might have other users over here or inserting data, and that would basically go into the East Coast database, and you're just going to replicate those writes over to this. So then instead of the user having to do a long trip to the East Coast to get their data from the API in the database, it could just have an API living over here as well, and it could fetch that data from its replica. Now, hopefully it's obvious why this would be a little bit faster for users to get the query versus over here. Now, from what I've seen with Postgres, typically you have a primary, I'll just say primary DB, and this is your replica DB. And all writes still need to go through the actual primary DB. So if you're trying to update your user's name or update some information, it still has to go to your primary database. But for doing queries, it can be a lot faster just to use a replica. Now, the first edge case with this approach is that it's eventually consistent, right? There's a line here. This takes time for this data, once it's written, to get propagated over to the replica. And so if you were to, for example, this user were to write into the East Coast, and then they try to read that same record, there could be a chance that it's not even going to exist or it's going to be out of date. So eventual consistency is an important thing to kind of point out, but there are ways to, I think, configure Postgres to be consistent. And then the internals of this would basically have to make sure that some of the replicas confirm the write before it even allows a user to query on it, right? Now, obviously, this type of setup is going to be more expensive. It's going to be a little bit more challenging unless you're using AWS RDS, which already has this kind of built into it. But still, configuring it can add some complexity. So if you can avoid it and your application is not that big, you could probably just stick to one database. Now, another thing I want to talk about is how exactly does this work? Like, how does the replication kind of work? And we're going to dive a little bit into the internals of Postgres, at least how I understand it, to make this work. So typically, you have a user that hits your API. The API is going to insert some data. So I'll just say like it does an insert. So the way I understand Postgres is that there's something called a WAL, a write-ahead log, which is going to write the data to this before it actually tries to insert it into its index files and its page files, I believe is what it's called. And then internally, whenever this Postgres database writes to the write-ahead log, it's going to keep track of something called a log sequence number. So it can know what is the last record that it wrote to this file. So if we take a step back, the write-ahead log is basically a way for the database to be able to, if it were to crash, when it comes back online, it knows what its last write sequence number is, and it can reconstruct or recreate the things that it was potentially supposed to commit to the page files and the index files. But the reason I'm telling you this is that the write-ahead log is actually important for the replication. So this replica, when you first come online, it's going to be very far behind. It's not going to have any data. So it's going to send over a request and say, this is my last log sequence number, in which the database will then send over all the information up to that point from the write-ahead log. So this one can actually have its own write-ahead log, and it's going to start populating that as well. Now, the second thing that's going to happen once it has its information is it's going to create a TCP connection that's basically always online, so that whenever the inserts happen in the primary database, it's going to send those over. So this will be send over new wall bytes. Okay, so every time this thing writes to the write-ahead log, it's actually including like some database information about what records were inserted, what values were changed, and it's going to send those over to the replica. And the replica is basically going to replay those to put inside of its write-ahead log, and then also to update its internal page file. And I think I'm saying the wrong thing. I think it's called heap files, and then also there's something called index files. So index files, which again, Postgres will eventually write these heap files and index files from its internal memory to disk, so that in the future, if it were to restart, it doesn't have to like refetch all of this data over again. Okay, but every time it's writing to this file, again, it's keeping track of that last sequence number that it has, so that in the future, if this thing crashes and it comes back online, it can send over, okay, this is the last sequence number. Maybe it's from 2 hours ago. this database will start streaming over all the data that it's missed, and then it can start getting up to speed with all the latest information. Now, I'll be honest, I'm not a database expert. I am trying to dive more into this to make sure I understand it so I can kind of discuss it and teach you all. But that's at a high level how I kind of understand it. But you guys can leave a comment if I said anything wrong, which I know you guys will anyway. All right, have a good day and happy coding. And leave a comment if there's anything else you want me to kind of dive into for diagramming or teaching, because I do enjoy making this kind of stuff.